Okay. Now we want dummy variables for the two factors. Okay. So we have to actually Chas is already a dummy variable, so we really didn't have to do that. But let's say that we want BH we need to make sure that, so if you simply did this, BHDF fact vars okay. So now what will happen is, okay, so those two are separated, but we have a data frame of just those two. But if you look at the structure, you see that they both are integer. They are not factors. So to create dummy variables, we need them to be factors. So how do you do that? So we can use lapply. We did this last time. Okay, lapply factor. Okay. Now lapply will, I think it's lapply will create a list, I think. Okay, let's see. So BH vars is that. It creates a list. Now let me see what. Let's see whether it can be. I wonder whether we can do a data frame. We may not be able to convert this into data frame. Oh, okay, that's good. So we have a data frame here. Okay, and now if you did str, okay, so they both are factors, so which is good. Okay. Now we can, I'm going to show you a method in Caret where you can create dummy variables. Okay, we have already seen creating dummy variables using model matrix. Okay, we saw that last time. So we can create dummy variables in this way. Again, okay, it has two parts. So you have to first create the object, and then you have to create the dummy variables using predict. So the second line will be, so you have bh dum.df. So that will be the predict. So that's how it will work. Okay. So here we have dummy vars is a method in Caret. You have to give a formula here, what variables we want. So we can say everything. All right. And then we want that. Okay. And then we can say bh dum.obj, okay, using that object upon this data set, so it will give you the dummy variables. Okay. So if you do bh dum.df, so you see chas 0 and chas 1 for the two values, and then rad 1 through 8 and then 24. Okay. The default is what you call full set of dummy variables. Yeah.
So when we do the pre-processing here, if the values are already like 0.4 and lower, would they become negatives? Would you scale?
When you do a range,
Yeah.
when you do a range normalization,
Yeah.
no. Okay, range normalization will always be between 0 and 1. So if you have a negative value, then that would be the minimum value, right? So you would go given value minus the minimum value. So like say you have minus 5 as the minimum value, okay? And you have minus 2 needs to be converted. So you'll have minus 2 minus 5 will be 3, and then you divide by the range, so it will be a positive number between 0 and 1. Okay. So here, okay, so this is good. The default is the entire set of dummy variables. I hope you see the difference. Here, chas has become two columns. Chas 0, one dummy variable, chas 1, one dummy variable. This is okay if it is distances like k and n, you don't have to worry about this. But in a model-based method like logistic regression, neural network, and things like that, you have to have full rank dummy variables. So that means if you have k categories, you can have only how many dummy variables? K minus 1. Okay. So this is not going to work for neural network. Okay. So what we have to do is to specify here. Oh, I have to say that here. When you set up, you have to say full rank equal to true. You have to say full rank equal to true. So that will give you only dummy variables for full rank. So now we have only one for chas, and then RAD 1 is not there. You have only for 2 to 8 and then 24. Okay. So full rank should be in the dummy vars method. Okay. So now we have the dummy variables set up. Now we have to assemble the data into the full data set. Okay. So let's call this BH prepped. Okay. So we do cbind. Okay. So we have the BH norm.df. That's the normalized data. And then we have the these dummy variables, and then we need the medv equal to medv. Okay. So now, if you look at BH prepped, so we have all of the variables. The numerical variables are range normalized. The factor variables are dummy variables. And then finally, we have the target ashes. So now we have the data prepared. Okay, and now we need to run the model.